Hello there, welcome to the A-Level Maths Period Paper 2 of June 2023. Here we're looking at question 9. The curve C has parametric equations of these equations here, show that the Cartesian equation for C can also be written like this, where A and B are constants. So what we're going to do is we're going to rearrange the x equation and substitute it into the y equation. So x equals t squared plus 6t minus 16. We're going to complete the square on this, so t plus 3 squared minus 9 minus 16. And then we're going to group together the two terms at the back, so it's now minus 25. Let's add the 25 onto the left. Let's then square root, plus or minus, equals t plus 3. And then subtract 3 to the other side, x plus 25 minus 3 equals t. I'm just looking over here at the domain for t. T has to be something that's bigger than minus 3. So in this case, if t is on the right hand side and it has to be bigger than minus 3, and we've already got minus 3, this term here with the square root in has to be positive, so we can ignore the square root. So I'm going to actually delete the plus or minus sign there because it has to be positive root x plus 25. So now let's substitute it into y. So it's 6 ln brackets, and the whole of the t equation I've just found is x plus 25, take away 3, add 3. So these two terms here, 3 and 3, can cancel out. So we're left with 6 ln root x plus 25. And then I'm going to take a factor of 2 out of this 6 and move the 2 inside the bracket as a power. And that will cancel out the square root. So it's going to become 3 ln x plus 25. And for the domain, I need x to be bigger than minus 25 because I don't want to have a negative ln. So there we are. A is 3, B is 25. Okay, let's move on to part B now. The curve C has parametric equation of this, and the curve C cuts the y-axis at point P. Show that the equation of the tangent to C at P can be written in this form, where A, B, and C are constants. So if it cuts the y-axis at point P, then x equals 0. So substituting in x equals 0 into the x equation, t squared plus 6t minus 16. So we're going to solve this. 8 and 2, I think, are the factors. It'll be plus 8 and minus 2. That will give the 6t, and it will give the minus 16 2. So t equals minus 8 and t equals 2. But t is a number bigger than minus 3, so it has to be t equals 2, and we can put a cross beneath that one. So I now know that t needs to be 2. Okay, so that's the first part. Now we need to do some differentiation to work out our gradient. So let's bring back in the form that we had before. The form we had before was 3 ln x plus 25. So y equals 3 ln x plus 25. And let's differentiate this. So dy by dx equals 3 over x plus 25. That's the differential. And now we're going to substitute in t equals 2. But we know that this is going to happen when, we found t. I suppose we don't need t. We need x. X equals 0. So the gradient at this point is 3 over 25. Okay, so now this is the equation y equals 3 over 25 x plus c. We need to now substitute in the x and the y value. Okay, so this is where we do need the t value. T is 2, we know that x is 0, and it's going to cut the y-axis at 6 ln 5. 6 ln 5, substituting in t is 2 into that point there. So we're going to get 6 ln 5 equals 3 over 25 times 0 at c. So ignore that. C is 6 ln 5. So therefore y equals 3 over 25 x plus 6 ln 5 times all the way through by 25 and move the x onto the other side. So it's going to be minus 3x add 25y equals 6 times 25 is 150, so 150 ln 5. And there we are, that's the answer to part B, with a total of 7 marks overall. Let's now move on to question 10.